Hey, welcome back to the Builder's Basement. Today we're jumping straight up into Klipper. We're going to take a look at the printer. We're going to do a couple things. We're going to kind of go through it point by point by point, getting Mainsail onto an SD card so you can get it installed on your Raspberry Pi, creating or making your firmware, and then inserting that into the Octopus, and then finally logging into our Mainsail instance and then going into our printer.config file and starting off on that. It's going to be a 2 or 3 part series of working with Klipper, Mainsail, Moonraker, those types of things. And yeah, so let's jump over to the printer right now, which is on its head so we can see the underside of it. And let's go over a couple little things over there. All right. So first things first, dangerous area. Okay, we went ahead and when we built this printer, we kept all of our AC power stuff over here. So pretty much that is our line. Everything over here we can consider dangerous. Everything over here is relatively safe. I say relatively safe because we have no AC power over here. We do have some 24 volt stuff going on, which isn't going to hurt you, but you might feel a tickle. That being said, we do not have any cards or anything inside of our, inside of our Pi or our Octopus at this point in time. But let's go over a couple things real quick. For one, we have a USB connection between our Raspberry Pi and our Octopus. This is USB type C. This is type B into the Raspberry Pi. I want to point out that this right here is your SD card slot on your Octopus. Okay, this is a reset button right here. There are multiple LEDs in here, but there's one right around this general area that is most important to us when we're flashing the firmware to the board. So we'll see that. Over here, and it's kind of hard to see, but on the backside, underside the board, right in the center over here is where the SD card gets inserted into a Raspberry Pi. Pins side facing up towards the PCB. There are 2 lights over here, a red one and a green one. The red one indicates power, the green one indicates an activity on the SD card. So that being said, that's kind of the general layout of that. I do have an Ethernet cable plugged into my Raspberry Pi. I prefer to do this and to run my printers on Ethernet, although I will quickly show you how to set up your Wi-Fi if you choose to use that. So first things first, we got that. Let's jump back over to the computer real quick and take a look at the software we're going to use. Software is all right. So there's a couple things that we can talk about here. First and foremost, we're going to be using Raspberry Pi Imager. There are other, and keep in mind, there are multiple ways of doing what we're doing here today, but this I think is the easiest, most concise way of doing it if you're just want to get it done. You know, you don't want to really learn command line too much. You don't want to learn how to set up a lot of stuff that you don't really want to get involved with. You want to get a printer working, right? So Raspberry Pi Imager, that is how we're going to put the image of MainsailOS, which is what we're going to be putting on this Pi, onto an SD card so we put it in the Raspberry Pi. Angry IP Scanner, that is a piece of software that allows us to scan our network and see what the IP address is of our new Raspberry Pi / MainsailOS instance. We're going to use Putty for SSHing into the Raspberry Pi. We're going to run a very few commands that we're actually going to just copy and paste straight out of a web page that I'm going to give you the information about. So that will also be in the description of the video down below, hopefully. If it's not, yell at me and I'll put them in. WinSCP is kind of like a file explorer for the Raspberry Pi when we're running SSL mode. And it allows us to drag and drop files out of it, much the same way we would in Windows or an Apple computer or anything like that. And that's the other thing, this is all happening on a Windows computer. This should work on Windows 7, 10, or 11. Last but not least, and we're actually probably not going to use it today, but we have Notepad++. The reason why I do think you should get Notepad++ is that if you are used to using normal Notepad in Windows, there are issues when Windows and Notepad save files. For one, it always wants to save a file as a TXT file. Yes, you can hit all files and then put in your own extension, but there are other things that happen too on that file, some heading information, some other stuff like that, that kind of, it modifies where it shouldn't. Notepad++ keeps everything in the raw as much as possible. So it's a good thing to have. So without further ado, we're going to get ourselves an SD card, micro SD card, one of these guys, if you get one. And well, you're going to need one. We're actually use 2 of those today. We're going to use one for our Klipper, or our Raspberry Pi, I should say. And then we're also going to use one for Klipper firmware that we're going to put onto the Octopus. So it's much easier with 2 SD cards, micro SD cards. There are other ways of doing it, but today we're focusing strictly on doing it with 2 micro SD cards. These are literally a dime a dozen these days, especially these small ones. This one's 128. You don't need much for the firmware one. The other one, talk about that for a quick second. I know the screen's kind of boring to look at, but actually, let me go to this real quick. On the other SD card that you're putting inside of your Raspberry Pi, it's going to live there a long, hopefully prosperous life. You're going to want something that's a few gigabytes at bare minimum, and the reason for that is because you're going to have a lot of configuration files on there. But on top of all that, it's also going to be a repository, if you will, of G-code files that you've already sliced that are on the printer, so that when you want to reprint something, you can easily go in there and just reselect that file and reprint it that way, as opposed to going on a computer, going back and dropping it, all those types of things. So it's handy dandy to have a decent sized SD card. I would say anything bigger than 16 gigabytes is probably doable. 32 is preferred. Up from there, if you want to go 64 and 128, it's probably overkill, unless you do a really large amount of printing and really big G-code files. But yeah, let's jump right into Raspberry Pi Imager. And I will tell you why I like this as I go. And I kind of have some ideas how to make this go by a little bit quicker without doing big pauses or anything like that. I'm going to show you some of the software while we're doing things. So Raspberry Pi Imager, it's going to pop you up something. You're going to hit OK on that. It's basically just okaying whether or not you can use it. Windows will sense the fact that this is basically going to write files to a drive on its own, and it has to get permission to do those types of things. So there's some permission things that happen. So we're going to scroll through this list. Actually, let me jump in the gun here. We're going to choose our OS, okay? And then we're going to scroll down this list. We're going to go to Other Specific Purpose OS. You have a bunch of other stuff in here. One of them, or the primary one here, is Raspberry Pi OS. That is the primary use of this particular piece of software. However, it's broadened over time. You do everything from making an arcade machine with this to a file server, a bunch of different stuff. Really handy software. Couldn't tell you how much you can do with this and how much I would tell you to use this software, at least if you're starting off with a Raspberry Pi, make it really easy. There are other softwares you can use to make your own images and put them on the Raspberry Pi, but this just makes it easy. So, other general purpose OS. Oh, whoops, sorry, my bad. Jeez. Other specific purpose OS. And right here on this list, the first thing on here, because it's alphanumeric, are 3D printing, and then you also have Home Assistant. Home Assistant's awesome. Maybe someday we'll do a video on that if you're interested. Leave a comment down below. We can talk about Home Assistant. This printer is actually going to be tied into my Home Assistant instance using a ESP32 board, so we'll talk about that too. And actually, if I am not, correct me if I'm wrong in the comments, but I believe the newest Prusa printer has an ESP on it, just for something similar to that. So, but I said it first here because I've been building this printer for months. So 3D printing, and here you got a couple selections. We have Octo Klipper Pi, Octo Pi, MainsailOS, Simply Pi. I'm not going to go into all these, but we're going to go with MainsailOS. It's going to run the Klipper firmware, and Mainsail, which is a nice, easy to use, low requirement in terms of resources on the Raspberry Pi GUI. It's web-based, and it will do everything that we need to do. So we're clicking on that. Two options here. You have a 64-bit and a 32-bit. You can pick whichever one you want. The 32-bit is recommended. For what reason? I don't know. Oddly enough, the 32-bit is slightly larger than the 64-bit, and I already have it cached on my computer, so there we go. It doesn't need to download it for me. So that's something to note. When you do this for the first time, it's going to download that file directly from the software. So it may not have it on your computer yet. All right, choose storage. So right here, it's going to come up with anything that you have that's a plug-in thumb drive. If you have multiple thumb drives plugged into your computer or multiple SD cards, you're going to want to know which SD card / thumb drive you're going to want the SD card that we're using for this particular project, so it can pick that one. I told you that I like to Ethernet onto my printers, but if we hit this cog here, first thing we want to do is we're going to set host name. We're going to enable SSH. We're going to use SSH. And we're going to use password authentication. I'm going to set the password and username to what normally these always are, which is a username of Pi and a password of Raspberry. You can do whatever you like, but this makes it easy for you to get help. If somebody needs to help you and they're trying to work you through it and you have no clue how to do command line, you have no clue how to work with the Raspberry Pi or Linux in general, you don't want to deal with the supplicant file, things like that. This will just help people help you if you need help. And you don't really need to worry too much about this username and password. It's only available on your local network unless you open up ports and do other things. So it's relatively safe. Right here, you have configure your wireless LAN. If you choose to do that, you can do that right here. Your SSD has to be exactly how your SSD is. Now, what that is the name of your Wi-Fi network. For instance, if your Wi-Fi network is called Belkin1234 or Linksys 55339, that's what's going to be. If it is your name with a number at the end of it, whatever it is, exactly the way it is, capitalizations, punctuation, which I don't think punctuation, you can do an SSIDs, but numbers, dashes, spaces, those types of things all need to be exactly. Same thing with your password, you're going to want to put that in here as well. Again, I'm not going to set up my my Wi-Fi right now on this printer. I might in the future, but for now I'm not going to. Like I said, I like Ethernet. Feel better about it. I am going to set locality settings or locale settings. Reason for that is keyboard stuff. Sometimes a keyboard input, if you have the wrong locality or locale. Anyways, if it's not set to the proper location of where you're at, some of the buttons may not match your keyboard. In different countries, some people have different lettering schemes. Sometimes the additional keys above, like number pads and things like that, are changed for different places. So make sure you choose what you have in your location. I'm going to go ahead and let it play a sound. We have eject media. I'm not going to enable telemetry, but I'm going to go ahead and save it at this point. I could have not done any of that if I wanted to. And I could have gone in and modified it after the fact, but this is easier to do right now. So once we've done all that, I'm going to go ahead and hit this right button. And it's going to tell me that it's basically going to wipe out whatever's on this SD card. So don't do it with an SD card that has a bunch of pictures on it or anything like that. This is going to be a blank SD card. And the only purpose for this card, after we do this, is to go into the Raspberry Pi and live in there for a long, hopefully fruitful and prosperous life. So I'm going to hit yes. And it's going to open it and it's going to start writing it. This is going to take a while. Not only is it going to take a while to write it, but that's going to verify it. I would say you're probably looking at about maybe a total of, I don't know, 10, 15 minutes at least. So while we're waiting that 10 or 15 minutes, let's go over the other software a little bit. Because one of the next things we're going to do is utilize Angry IP Scanner to find out what our IP address is of our Raspberry Pi once we put the SD card in there and we boot it up, and it has a moment to do that. So Angry IP Scanner, if you're not familiar with IP scheming and networks, basically it requires you to put in your IP range. Most home networks are 192, but you could have a 10 dot network, or you could have a bunch of different things. The easiest way to find out what you have is to go into network settings of your computer and check what your Ethernet, your IP address is of your computer, not the one on the internet, but the one on your computer itself. If it's a 192.168.1. whatever, this is going to work straight out the box. If it isn't, you're going to have to modify these numbers. For the most part, you do want to start at 0 and you want to go to 255, so you get the whole span of IP addresses that are under that same subnet that you're on, assuming your printer is on the same subnet as your computer, which I suggest it is. And then basically, once we do that, we're going to hit the start button. It's kind of frivolous to do it right now because it's not working. So I'm going to slide this off of this screen right now. and this is still writing. It's at 20%. And we're going to open up WinSCP. WinSCP already has this, but I'm going to close that right now because we're going to just go over this interface a little bit. And I'm actually going to bring this down because I cut off the top of my screen because that's usually where the junk is. Yeah. So anyways, this is what it looks like. Let me get it on the screen completely for you. This is what it looks like. And on one side, on the left-hand side, you have your local machine. On the right-hand side, you're going to have the machine you're remoted into. So right now there's nothing on it because we're not remoting into the machine because it's not there yet. Again, we'll go through those steps in a few moments. But over here, you're going to have a drop-down, and this drop-down gives you a selection of places where you can look. Desktop, my documents, different drives and whatnot. I usually just aim for my desktop, which has a lot of junk on it right now just because I've been downloading a lot of things, working on a bunch of different things. But this is kind of where this is going to wind up. So right here, if I need to check for updates, anything like that, it's good. You do want to make sure you update your software when you can. Here's a refresh for that. Over here is a file tree. And then basically, I can't show you all that much more on this until we can actually connect to it. So I'm going to slide that one aside too. While we wait for that, we'll get into Putty real quick. Putty is a very super simple program that uses an SSH protocol, which allows us to basically command line-ish talk to another device. The thing is, you got to remember, is command line or typing in words on a screen a lot of times is quicker and easier than using a GUI, a GUI. And I'll explain myself for that. GUIs are great because they're graphical and people can get a grasp on them relatively quickly. The problem with a GUI is you have to know where to click and where to look and where to go to kind of do things. Yeah, it's great to have a big red raspberry right here in this corner and know that that's my Raspberry Pi imager and I can see it, but I have to know it's on this screen, and this is relatively easy because it's on my home screen. But where's this program really? It has this little arrow. I know this is a shortcut, and I know I can go into properties, I can find it, but some people don't know those things. So if I actually had to find the root of where that actual program resides, it might be kind of difficult. On command line, as long as you know what words to type, it's real easy. You might have to move around to different directories and things like that, but again, you're just typing in words. It can be quicker than using a GUI in a lot of cases. So don't be afraid of a command line interface, especially when you're only using it here for an SSH, or maybe a couple of other things you might wind up doing down the road. I'm gonna set this one aside too. All right, last but not least, well, this is at 59%, and I'm probably gonna wind up pausing the video so we can finish this up in terms of the writing and the verifying. It's Notepad++. Again, I don't think we're going to use this today, but let's see here. I'm going to bring this down, and this is just an awesome, I wouldn't use this to write papers or anything like that, but it has some great tools for comparing things. It has some great tools for, it'll actually color code a lot of times based on indents and things like that. It's a very smart piece of software. It's very small. And it works very well. If you're doing anything with text files in general, whether they be config files or log files or anything like that, this is definitely the way you want to go to be able to see things to their fullest. Whoops, I keep on bringing things down, I forget. So I definitely suggest you get Notepad++, even if we're not using it today. There might be another day where you do use that. So I'm going to close that because I'm not going to be using that today. So now we're at 72%. I'm going to go ahead and pause this video real quick, and then we'll come back once that writing has finished and it has been fully verified. See you in a bit. And welcome back. So we gone ahead and we've done that formatting. We've gone ahead and done that. Well, we didn't format, it was already formatted, but it formatted it again. But we've gone ahead and we've gone ahead and written our MainsailOS to our SD card. It's gone and verified that it's all done. So let's jump back into that screen real quick. That's where the fun begins. This is all fun, right? You're gonna get a pop-up, tells you you need to format the disk. The reason for this is because this disk, this SD card disk, is now formatted for Linux. So not to be confused, there is a portion of this SD card you can still see on a Windows machine. That's also where the supplicant file is. Again, we don't modify and open that up with Notepad if we ever do want to modify that, and that's where we put our some information about our Wi-Fi and things like that if we want to make some modifications. I'm going to skip all that today again because I just showed you how to use that little cog when you're writing the file to put that Wi-Fi information if you choose to. So I'm going to X out of that. Yes, I know it's unavailable. I don't want anything to do with it. I don't want to format this. I want to cancel. I want to see this right here. This is what I believe in. This is the truth. We have now installed MainsailOS on that SD card, and it has basically got all done, and we can close this program and we can grab our SD card. Okay, boom, SD card. This is the magic key. We're gonna go put the magic key into the magic little computer now. All right, as I said before, I'm gonna move this wire just a little bit. This goes with pins, I don't know how much you can see, but I think it's pretty good. Pin side up towards the PCB here. And I know stuff's a little cramped, but I didn't want to do it out of the printer. That would just be odd for me, at least. I guess you probably could, but you'd have to provide power to everything and have everything wired up separately. So the SD card's in now. Everything's good. We talked about all this before. We're not doing anything with this just yet because we need to build our firmware on a Raspberry Pi. So we're going to switch this on. I want you to look. I'm going to see if I can block some of this light right here, but we're going to see, try to keep my hands safe from that AC power. We're going to see if you see that green, that red light. Red light should come on instantly. Green light should be flashing. So there you go. There's a red light right here, a green light that's flashing. Those quick flashes mean it's doing read and writes. It's going to go off, it's going to do some rewrite. In between it's processing, it's doing those types of things. So we're going to let that go for a moment. Come watch that. I know it's kind of hard to see on the camera because it's bright over there. So I can kind of have something for everybody can see. What we're going to do as an extra step is we're going to go to our Windows bar down here. I'm going to write CMD, and that is for the command prompt. And let me bring that over, and then let me go back to the screen share. There's a lot of screen share on this video, so hopefully it doesn't bug you guys out. This is a command prompt. Again, you can get to it by going CMD on a run or going right to the Windows and hitting CMD. I already know that this Raspberry Pi is going to come up. I've already kind of put a statement in my router. It should come up as 164. So I'm going to do this. I'm going to do ping 192.168.1.164 as the IP address that I expect it to come up at. Go ahead, -T on the end of that. I'm going to run that, and basically that's going to continuously run for a while here. And eventually those should come up and it should tell me that that Raspberry Pi is there. Mind you, yours will not have that address on it, and you probably can't do this right here. Actually, I typed in the wrong address. Control C and up arrow. Oh, that's right. Okay. There we go. So it's now replying, so that means that it's booted. We have Raspberry Pi that's booted up. It has an OS on it. It has the rudimentary stuff in there to actually so that when this computer is sending it a ping, it can respond with a hello. So I'm going to close this out. We don't need this anymore. And because we know that, just not to jump the gun by too much, but I'm going to bring up a web browser here, and I'm going to drop this down a little bit just to show you what I'm doing. I'm going to open up a new here, and I'm going to go 192.168.1.164, and we have a web interface. There's not much we can do right here right now. My control board actually does have Klipper on it, but we're going to reinstall Klipper because we're going to go through everything. So this is what you'd see if you had a non-configured interface right now with Klipper on an MCU. If we did not have Klipper on MCU, you'd have a secondary error on here up near this area, or possibly that area, but up in this area where it tells you that it, basically Moonraker wasn't able to talk to Klipper, the firmware. So we'll minimize this for now, and I'm going to still show you Angry IP, and it just makes it easier. I hope you understand that I'm doing this in a way so it makes it easier for you to understand, because I know what my IP address is, so I can show you what to look for in Angry IP Scanner. If I went through this the longer way, you know, it's going to take longer. It's going to take you longer if you're not fully familiar with your network and things like that, and you have to use these tools and you're kind of doing some pecking around. This video is strictly kind of going through all the steps for you to help you out. Don't expect it to take the same amount of time. You know what? Or it could, if you've done it before and you just refresher, you're going to hammer right through this. It's pretty good. It's pretty easy. So what this is doing is scanning all the IP addresses in there. Once it sees something or doesn't see something, it's basically going to go back to those and say, okay, what ports are available? So this is my router. It has a 2 millisecond ping time because it's really local, and ports 80 and 443 are available on it. It's all done. So I'm going to scroll down. I'm going to bypass all the red ones here. These are nothing. I'm looking for stuff that has available ports on it. Okay. So I can see right here I have my Home Assistant. It doesn't see any viable ports on it, which is a good thing. Nothing wrong with that. I can see my FluidPi. So FluidPi, or Fluid, is much like Mainsail, only different. It's a different web GUI interface, but that is my other printer, and that's at 107. I totally agree. That is where it is. Let's see here, and then we're gonna keep going down, and we're gonna go down here to 164, where it says Raspberry Pi.local. So that has port 80 open, which is a normal web port. Ports 80 and 8080 tend to be the normal web ports. So there's how you find that, and that is what you're going to be looking for, something called Raspberry Pi.local. You could also try typing that in your browser, Raspberry Pi.local, and it may or may not work for you. It depends on how your routing is in your system. But right here on the far left is the IP address, which is why that IP address worked for us. So IP range, Angry IP Scanner, there you go, nutshell, close it down. Good. Next thing we're going to do is I am going to bring up our web, actually, let's do this first. We know we're going to 192.168.1.164 on this SSH. So we're going to do that. We're going to set potential security breach. It's not. Trust me, it's not. I'm going to drag this over to the side here, okay? And I'm going to bring up this right here. And I'm going to now bring up this Voron design page. Now, I'm going to try to get all this stuff inside of the description down below, but right now I'm going to basically spell this out for you. If you're watching this video and you got a pen handy, or you're the type of person who likes to make notes as opposed to watch videos and copy and paste stuff, it's very simple. It's docs, docs.voron.design.com/build/software/Octopus_Klipper.html. So this is the actual Voron design team's instructions on how to install Klipper on an Octopus or an Octopus Pro. So they are telling you right here, right off the bat, the prerequisite not to have HEO or HE1 connected. Again, we talked about this a little bit in the beginning. I don't have my all of my connections made on my Octopus, and that is on purpose. I believe, personally, I prefer, I should say, that if you have your software running on your Raspberry Pi and on your board before you hook up all your connections, then you can easily verify your connections. You can do it the other way around if you like, but then you have to disable some things, you have to unplug things, and why not just have it right the first time when you're doing it, and then you can go through and do your testing at the same time. Hell, you can connect one thing at a time and test them out if you'd like. So this is the way I like to do it. May not be the way you like to do it. Okay, I'm gonna slide this down a little bit because you can't see the top, but I wanna log in, and again, we talked about this earlier, but I'm logging in as Pi, and the password, which is going to stay blank even when you're typing, is Raspberry. Oh. Well, that's odd. We lost our network connection. I wonder why. All right. Well, let's go ahead and reopen Putty. and do a 192.168.1.164 and pi. Move that back down again. And Raspberry. And there we go. All right, I'm gonna slide this back over here again, put that back over here. Okay, so, and it is kind of cut off on top a little bit, but you're not missing much. Just some no warranty stuff and blah, blah, blah. So prerequisites here that we're seeing is Klipper must be installed on your Raspberry Pi. We've done that. If desirable, strictly not necessary to have an SD card available. That is the second SD card that we have right here. I do agree. That is very much preferable, depending on how you do it. We're going to log into Raspberry Pi. We do not need to do the sudo apt install make. We do need to get into the Klipper directory. We do need to make, and we do need to do the Makemenu config. So before we get too far into this, I'm going to teach you a little bit about this command line. I'm going to tell you what sudo is. Sudo is super user do. And basically you can put that in front of almost any line and it'll be fine. If you don't put it in front of some lines, you might run into trouble. In this particular case, we don't need to do it because we're not doing an app install or anything like that. What it does is it pretty much asks you to, it's almost like running things as administrator in Windows. It asks you to confirm your password and then it allows you to do that. If you don't do that, it might just say, nope, we don't know who you are. We don't exactly trust you. So we're gonna skip that. We're gonna do the CD though. We're gonna do change directory or CD, and then we're gonna do squiggly /Klipper. So that puts us in the Klipper directory. Now, if we didn't know what that directory was, we could do ls, which shows us the directories in there as well as the files. So basically these dark bluish purple ones are directories, the white ones are files. Just so you know, that's an ls. One other thing I'll tell you real quick is the up arrow lets you repeat what you already done. So if you miss something, like for instance, I do CD Klipper and I forget the R and I get an error, I can hit that up arrow and I can put my R in and it actually works. So up arrow will save from typing a lot of stuff a lot of times. So check my phone real quick. So we're in a proper directory now. We're following this through. We're gonna do make clean. Oh, helps if I'm on the right thing here. Make clean. We're on this line right here. And we've done that. And now we're going to do make menu and then config like so. And this is going to bring up this menu, okay? And I need to bring it down so we can all see what we're doing here. Putty and command line don't need to be full screen, but we're going to go through here and I'll kind of explain what you're doing as you're doing it. Kind of have to sneeze. So they're telling us first things first, we want to enable low-level configuration options, and what that does is basically opens up, it's more like an advanced menu or a extended menu of things we can do. To do that on this screen, we can hit enter or we can hit space. I prefer to hit space and keep enter for other things. So I hit space and that went ahead and that opened the low-level configuration. So microcontroller architecture is basically what CPU, what is controlling your microcontroller. In the reference of an Octopus, you have two options there, but they are both STM, and to my knowledge, most most controller boards use STM hardware. So we're gonna hit enter to get into that menu. We're gonna go down to STM32. Okay, we did that, and then this menu pops up, processor model. Okay, I know for a fact because I can see it on my chip, and I know what version it is, that it is a STM446. Let's go over to that real quick just so I can show you what that looks like. If you have any doubts as to what version of a chip you have, this big chip in the middle is basically what the processor is for this controller. It's what controls everything. Everything's pretty much connected to that chip in some way, shape, or form. On that chip, you're going to see letters and numbers. This one says STM32F446, which matches what we chose. You can look at your chip to verify that, and I do suggest you do, especially if you're not using an Octopus. Okay, back to our screen. All right, so we have the 446, and it tells us right here that you choose 446 or a F429 if you have a motherboard that has that. So bootloader offset is 32 kilobits, which can be 64 or no bootloader. A bootloader is basically a pre-boot. It's a pre-amount of code that's on a chip, and it is very useful in case something goes wrong. It allows you to kind of go backwards and fix something that's wrong. If there's no bootloader on a chip, it can be very difficult at times to rewrite a chip that has something that has faulted on it. So bootloader is good, right? Clock reference, it tells us right here that we're looking at a 12 megahertz clock reference. If it didn't, we could look through the manual. I do suggest you get yourself the big Tree Tech manual for your Octopus. You don't need it in paper format, but having a copy of it's good to have. So I'm going to click on that, and we're going to change that to 12. Communication, USB on PA1112, and that is what we're using here too. Does it say? Yeah, right here, communication USB PA on basically pins 11 and 12. So we're utilizing USB for the Octopus to talk to the Raspberry Pi, which is why we're leaving it like that. The other options are going to be, keep on getting off the screen, are going to be UARTs, which is a serial interface, or CAN bus, okay? We're not doing CAN bus on this printer, but we're going to do that in the future on the other printer when we redo it. So I'm gonna hit escape to get out of that menu. That'll bring me back one. USB IDs, I don't need to do anything with that right now. And GPIO pins for microcontrol startup, I don't need to do anything with that right now either. So we're pretty much done here, and I'm just going to look over here. These screens right here kind of show you what you should be looking at. They look slightly different because they're using a different software they're connecting to, because this this text that you're looking at over here is based on what Putty is making for us, not what the printer or Pi is putting out. So these can look different, and you're okay. It's fine. The words will be the same. The look might be a little bit different depending on what you use to connect via SSH. So we go down, and now they want us to press Q to quit, which sounds about right. We'll hit yes to save that configuration, and it kicks us back out to our session, okay? So once we're at our session, we now want to do a make. And what make is going to do, it's going to run down, it's going to create and build and compile. And what it is compiling specifically is our firmware to put on the Octopus. This is only gonna take a few seconds, maybe up to a minute or so, but it's gonna go through there, it's going to do all that. We're gonna wind up with a file. And we'll twiddle our thumbs for a few seconds while it does that. It's almost done. It's building out, compile time, linking, one more, I think one more line, maybe two. Klipper.elf, come on. There we go. All right, creating Klipper file, hex out Klipper.bin. Perfect. Klipper.bin sounds like an awesome file, but it's not awesome enough to go into our Octopus just yet. Reason being, it has the wrong name. All right, so what they're saying here is, let's see here, firmware installing your printer, yep, okay, make, yep, da-da-da. So now they're talking about how to get that firmware onto the Octopus. And we're gonna not follow this necessarily to a T, but pretty close. So do pay attention to the video if you are using this as a reference along with the written guide here that, again, I will try to put in the video information down below. So first thing they want us to do is go into our Klipper directory by doing a CD and then get into Klipper. We've already done that. We're already there. We don't need to do that again. What I'm going to show you now is what we can do now. If we want to, we could type this out completely, or you can just simply copy. And then as soon as you right click, I'm going to left click, and so I'm on this window for my Putty session, but as soon as I right click, it's going to automatically paste. See, like that. If I hit enter, it's done. It just basically now converted that file to firmware.bin from Klipper.bin, because firmware.bin will go on to that controller board, but Klipper.bin would not. The board would not recognize it. It wouldn't care. So earlier I showed you the ls command. I'm gonna hit that again. And then I know, but I also know based on that last command that out is the directory that this happened in. So I'm gonna do a cd space OUT to go into that directory. Now I am currently in that directory. I'm gonna do ls to list And I can see in here that I do indeed have a file right here called firmware.bin. If I had gone in a few seconds ago, it would have said Klipper.bin. So we're good. Perfect. It's right where we want to be. Trying to think now. Yeah, I think we're good. Yep. So I'm going to leave this open. And I'm going to now bring over our WinSCP that we talked about a few moments ago. Kind of give you a quick rundown on that. We're still in our desktop over here, but we're not connected to anything over here. So I want to, let's see here. I forget how to connect. Local, go to, refresh, change drive, add path. You know what I'm going to do? Just because I forgot how to do that, I'm just going to reopen it. It's going to want me to connect instantly anyways. If I hadn't had this in here, it's as simple as typing in that IP address and then connecting. I'm going to hit login. Yes, I know. Security breach, yes. My password again, we'd use Pi, Raspberry. There we go. And because I've been here before, it brought me directly to the directory. If I wasn't in the proper directory, you basically can go through and find that. Again, it's on the out directory in the Klipper. So basically you look for the Klipper directory. Inside that Klipper directory, you look for the out directory. In the out directory, you'd find the firmware.bin. It's not highlighted green here, but trust me when I say that is the proper one. So now we're going to need our second SD card, which is already formatted with FAT32. You do want to use FAT32 for your cards when you're doing this. I don't know if anything has been written on that, but I greatly suggest that. And I'm going to basically minimize that. And I'm going to switch this right to my SD card. And I am just going to simply take firmware.bin and drag it over. Okay. Now my firmware is on that SD card. It's as easy as that. Okay. So I'm going to X out of the software because we're all done. And I'm now going to go, and I can't show you because it's over on another screen, but on the lower right-hand corner of my primary screen, if I click on the up arrow in Windows 10 or 11, you get kind of the running programs. One of them look like a thumb drive. You want to right-click on that and hit Eject New Volume. You'll get a little pop-up window that tells you it's safe to remove it. It's not 100% necessary to do it, but I suggest you do it anyways. So now we have our firmware file. And off to the races we go. All right, so earlier I talked about lights on the controller board as well as the Pi. There are a few lights over here, one over there, and there's one in particular right about where I'm pointing that might be kind of hard to see. I can't really tell what's hard to see and what isn't. But right here in the middle of some header pins, there's a red light that's important to us. There's also a blue light over here. So I'm going to take this card, and I'm actually going to insert it with it on. Some people tell you to turn it off, but it's not a must. That blue light came on, so that tells me it knows there's a card there, but nothing happened with that red light, okay? That's because it's not going to boot and then load the firmware. The only time it will load firmware is on a fresh reboot. I told you earlier we have a reset button right here. I'm gonna hit that reset button just for a second and let go. Did you see that? Did you see that blink and then come back full red? That's how long it took to load the firmware on this card. It takes literally under 2 seconds, okay? Once that's done, I can go ahead and remove this card. It doesn't need to be there. Card stays in the Pi, doesn't need to stay into that. So that should have the proper firmware on it now. And now that that's happened, I'm gonna go ahead and reset it one more time. There we go. All right, and back to the screens we go. All right, let's bring that browser right back up. And this time, let's broaden this out a little bit. And let's bring up our printer and refresh this. And we're still going to get some errors here, right here specifically, okay? At this point, the printer has Klipper and, well, the printer. The Raspberry Pi has all the things it needs, the prerequisites it needs to run, and our controller board is running firmware that it needs to be controlled by the Raspberry Pi, and then control the stepper motors and other things that are connected to it. Think of it as the Raspberry Pi being the brain, and for lack of better terminology, the MCU is being a master control unit, or the spinal column with all the nerves going out to all the things that are connected to it, okay? It's kind of a good analogy, but not great. So the first thing it's saying is it's unable to open a config file. It's looking for a printer.config file. Well, that's interesting. There's no configuration at all in this. No, there isn't, but not a big deal. So if we go to LDO's GitHub, and specifically, we're looking, and I'll again try to leave these all down below, but inside of the LDO GitHub, we're looking for blob, LDO Voron 2 / blob / main / firmware / Octopus printer, Octopus printer rev-a.config. I'm gonna go back one here just to show you what it is before we get to the .a config and kind of tell this to you a little bit. There's a rev-a config and a rev-c config. Rev-c, the way you know you have a rev-c requirement is that it's done away with the mini 12864 screen and it's gone to the 4.3-inch touch panel. That's the big thing right there. So you'll see in your kit, if you have a touch panel screen, you need the rev-c. If you don't have that, you're gonna need the rev-a. And click on rev-a, and this isn't really what they call raw text, but it's raw enough for what we need. You can click raw here and it will open up separately. I'll show you that real quick. And then basically you just have text that's on the side of the window. We don't need to do that though, because we're just gonna copy this. I'm gonna put my cursor up here, right at the beginning, right where the first hash is, and I'm gonna scroll all the way down to the bottom, all the way to the end here. And then I'm going to hit the shift button on my keyboard and then click right here at this end, and I've selected all the text. I'm going to right click on it, I'm going to hit copy, okay? Now I'm going to come back over to my printer, which we recognize as being the .1.164 printer, and I'm going to click over here on where it says machine. These are our config files for Klipper, okay? So this is basically where Klipper stores all the files that it will use on a Raspberry Pi. Now, there is no printer.cfg file currently because it does not come with one. And that's on purpose because those config files are pretty long and modifications can get pretty deep. So I'm going to go ahead and create a file. I'm going to call it printer.cfg. That's what it's looking for. Hit create, okay? So now that I've created it, I can go into it. It's completely blank. I hit Control V for paste, and I'm going to paste in that preliminary file, the configuration file there. And I'm going to do something. And again, there's some things that if you've done this before, you know that you need to do other things, but I'm just doing this again for some educational things. I'm going to hit save and reset because I want to save that file with the updates on it. I'm not going to go and add other things in here or make any modifications just yet. So I'm going to hit save and reset. It's going to reset. It's going to retalk to Klipper. And now you'll see that these errors have changed. It's saying now option position max section stepper Z must be specified. So recently, a friend of mine, the Poor Boy channel, was having issues with his Klipper file. So I want to spend a couple minutes talking about the Klipper file and also talking about how this particular box can help you out to figure out where your issues are. We still have this up over here, but that's a machine, and we have our printer config, so it's not airing on that, but I'm going to go back into my printer config right now. And before I do any of that, I want to talk about this right here. So right now, my Raspberry Pi, even though it was used and we put firmware on the MCU, Raspberry Pi doesn't know what the address is. You know, it's a next door neighbor, but you know, is it one house over based on the address, or is it two numbers over, or is it odd or even? It doesn't know. So we need to tell it what it is. So we need to get back Putty, okay? And then just for ease here, let me come back to this. There is a command right here. I'm just going to highlight this, okay? And basically this is an LS or LIS device serial by ID. So it wants to list all devices that are on the serial bus by their IDs, is what that is. So I'm gonna paste that right in like that. I'm gonna hit enter, okay? Right there is the serial ID of our MCU as Klipper sees it. So it's Google Earth for the Raspberry Pi. And then we're gonna just copy that. And I'm gonna close it down again and go back into here. And right here where it says replace with your serial, I'm going to delete where it says replace with your serial. I'm not going to delete the rest of this. We need to keep this device serial by ID. I'm gonna paste in what we just had. And now our Raspberry Pi can talk properly to our MCU. Again, I'm gonna hit save and reset. Hitting save and reset once you make changes is a smart thing to do because it will save them. Okay, so now that that's done, and it will not change anything, but at least it's done. It can now communicate properly when it has time to. We can start going through here and kind of look for fixing those things. Let's talk about the printer config real quick. I'm gonna wrap this video up in about another 5-10 minutes because I don't wanna make it too long. We'll have a part 2 to this, but let's talk about the primary basics of printer config. At the top here, there's a bunch of information about how you should set up your make file and things like that. There's also a bunch of information on here about what certain things mean, about certain pins and things like that. And these double hashes pretty much mean that they're in there by system. If you see a single hash, not that one in particular, but like right here. So if you have information in the front and then you have a single hash after it and then some information, that information is not for the printer, it's for you. That is not readable information for the printer, it's readable for you. So right here, it's telling us that based on their kit, they have 3000 on here as your max acceleration. However, if you want to max it out completely, you go to 4000. That's why they wrote that. Right here, max Z, 15, max 15 for 12 volt TMC drivers. You can increase if you have 24 volt TMC drivers. So it's written, it's a note. Further on, you're gonna see that there are sections where there are hashes in front of other things. And this is kind of like a BYO DIY thing here. So it's telling you right here, if you're doing a 300mm build, uncomment this. So what I suggest you do is hit Control F for find, and we're just going to go through and find everywhere as it says 300, because this is a 300 build. If it's 350, type 350. If it was a 250, type 250. So I'm going to type 300 in here, and it's going to start finding all those, okay? So I'm going to delete out the hash for that. I'm going to delete out this one below it. I'm going to leave all the other ones because this is a 300mm build. I'm going to hit next. It's going to jump. It's going to find all the 300s. Oh, down here in purple, 300. Uncomment for 300 build. Again, delete that. It's my max position. Changes based on how big your build is. Hit next again. This 300, I'm not going to do anything with it. It's talking about other things. I can easily see that. It's not talking about the build. Here, gantry corners, 300mm build, uncomment for 300mm build. On this one, since it has a single hash, we'll get rid of that. And this is basically calling out where the corners are of our gantry. So I'm going to go through, get rid of these. This one with the double, I'm going to leave it because that is a note that's going to stay. Okay, we've done that. So what I'm going to do next again, go for our 300s. Again, that's 300s calling out a piece of data. We're not going to modify that. It's not part of the build. Right here, uncomment for 300 build. This is a macro for the G32, okay? So right here, we're going to uncomment this for that. And that basically is given X, Y, Z coordinates for that G32. This is actually a start code. So basically it's going to go through, it's going to do its leveling, all that type of stuff. So I'm going to hit next again. And again, it's a 300 we're not going to modify. We obviously know that. We got the acceleration, stuff like that. I know I'm at the top of the file again here, but we're going to go back down through and we're going to see that we've already uncommented. Actually, we didn't uncomment this one yet for a 300mm build. So we're going to comment this. What is this? oh, and stop information. Okay. And then we're gonna hit next, 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 next. That's already uncommented. Now if we go through it a couple more, we should see that we already got them uncommented. We do. Again, I'm gonna hit save and reset. We've now officially kind of told this software that we have 300. Now, what's this error happening? Oh, MCU shutdown, ADC out of range. Oh man, not a big deal. What this is telling us is that the software is working properly at this point. We've actually gone to like the 75, 85% point to actually have a running printer, maybe 90%. The reason why this is popping up is because we don't have all our connections made. It's warning us and protecting itself by shutting down because it's not seeing those temperature probes. If we look right here at this, generally occurs when a heater temperature exceeds its configured min or max temperature. Once the underlying issue has been corrected, use firmware restart command to restart the firmware, reload config, and restart the host software. Your printer is shut down. So that's a good thing because we don't have everything connected and the printer doesn't see it. So to the printer, it could be heating up, or you could have a hot end that's at 300 degrees Celsius, but it doesn't know and it doesn't like that. So it shuts itself down. It's smart, okay? All right, let's look at this dashboard a little bit. And next time we come in here, we'll look a little bit more. And there's not much we can look at right now because this is up and I kind of forgot that. But I wanted to look at the console. So the console is much like command line like we were using before, only this console uses G code and some other codes that you can use there, M codes, G codes, things in there to kind of tell the printer to do stuff. And we're gonna have a whole interface here eventually. Over here, we have a full console. We have G code files right here. These are our uploaded files, or we can upload a file. We can also delete files. We can do file management in here. A G code viewer. This shows our actual G code file as it would be seen in a 3D format. So this is much the same as your slicer. It's gonna show us a lot of things about that. And you can actually move it and things like that. It's really nice. One of the things that Mainsail does. History is gonna show us the things we've printed, how much print time we've had, all those types of things. Then finally back down here in machine, we have our configuration files. Up here, we have config examples, which we could always go in here and get our printer.config. Where is it here? Rotary extension. They used to have one in here. Oh, there's more than one page. Let's see, generic big tree, example. Let me see, there's gotta be a printer. Yeah, right here. These actually are ones for different, there's big tree ones, there's Creality ones, Duets, Physics, a bunch of Mighty Board, Minitronics, Mellow. So a bunch of different configs here for a bunch of different things. It looks like there's 204 different configs available on here. So those are config examples. We also have docs. So these documents they're documents, how you can read it. Let's click on sponsors just for the heck of it. This is showing us sponsors, people who have helped out with Klipper in general. You got Big Tree Tech, Kevin O'Connor, who's primary on this, and then Eric Callahan, as well as some other stuff in there as well. Okay, yeah, X out of that. Again, this is just docs. Last but not least, we have logs. When you install this method, you get a product called, or a server called Crow's Nest. Crow's Nest allows you to have your cameras on here. You can actually have multiple cameras. I don't know what the maximum is, but you can definitely do 2 or 3 cameras you want. We're gonna have 2 cameras on this. We're gonna have a nozzle cam as well as a print cam. So there's a log for that. There's a Clippy log, access log, error log, moonraker log, and then a backup log from before. So these are all your logs. So go back here to our config, and we're right here. And I want to look at the screen just for a second. Right here, we have an update manager. Once we have our printer completely running, we're going to go through and make sure all of our software is up to date. We have a little dashboard here that tells us about our system, how much memory we're using, how much CPU we're using, temperatures of those things like that. And then basically we can download our log files if we choose to. All right, this has been a really fun video. I think I've gone through it just as well as anybody else has, if not better, hopefully, right? And I hope this helps you out a million times over. It's been real fun. just to let you know, my channel is now monetized. So if you do want to drop me a super chat or something when we do a live thing, or if you want to do I think you can join my channel, a subscription or something on the channel, I have that. I'm more than happy to get a little bit here and there to help me out, to fund things that I buy, to do videos on, things like that. But by no means do I expect you to do anything. I do this for the fun of me, for one, for the hobby of it, but also try to help out some people. I want to give a big shout out to all the patrons I have right now. Big shout out to Woody. Woody's building a printer right now. Been doing a lot of work with him. Big shout out to the First Slayer. Excuse me, Rich over there. Golden Jaguar, DeWitt 3D. Bunch of people out there. So you guys all been great. Hopefully I catch you on this weekend's live. I think maybe I'm going to open up a Zoom or something, maybe have somebody or allow somebody to call in if they want to. So maybe I'll see you there. Next version or next episode of this will be us going through and kind of getting the wiring done on the actual MCU, and then going through pin configurations and kind of digging a little bit deeper. But once you get to this point, this is the scary stuff for a lot of people. I think you'll be well on your way. So if you've gotten to this point through here and you're able to follow through, you should be good. Anyways, long and short of the whole thing, I really appreciate your time. Appreciate you guys watching, and I will see you next time.